Hola, chaps. Let's learn. Hola, chaps. Mr. Turek here. This is for chemistry chalk activity. In this activity, you are to take a piece of colored chalk, measure it, how much it weighs on a kitchen scale, go outside and spend 5 minutes doing some upbeat, positive, creative artwork, and then remeasure your chalk. So, here we have a kitchen scale and 3 colorful pieces of chalk. Now the instructions only call for 1 piece of chalk, but my wife Linda thinks these are pretty colors, and therefore she's going to use 3 pieces of chalk. So how do we do that? What we're going to have to do is measure the total mass of all 3 pieces at the same time. So here we go. Alright, put on the 3 pieces. Oops. This old house is not perfectly square and level, as you might get. And in celebration of pi, we measure a total mass of 8.0 grams. Now the next step is to go outside and spend 5 minutes creatively drawing artwork on our sidewalk. Alright, we're out on the sidewalk. You probably can't read this, but I set my timer for 5 minutes and Linda is ready to start, so start. Alright, so the 5 minutes have gone by and we have our 5 minutes worth of artwork created on this. What do we got?
Hashtag Orange Coast BNI. Woohoo!
And what does BNI stand for?
Stands for Business Network International. And then hashtag Cerritos High. Woohoo! And then stay strong. And then hashtag Silver Moon Photography. We love you.
And LJ.
Yeah, well, you know, you got to sign your work.
Ta-da! Alright, so now we take the chalk back indoors and we reweigh all of it. Here we go. Alright, so here we are back inside, powering up the same kitchen scales, and the 3 pieces together now measure 60 grams. And so when I said it was 8.0 grams before, I misspoke. It was actually 80 grams, and now it's gone down to 60 grams. There's your data. Hola, chaps. So in addition to doing the chalk activity, I also have assigned for you to do a worksheet, and the worksheet is molar mass, grams, moles, and molecules. Of course, I don't want to do the worksheet for you, but I am okay with the idea of doing an example of this type of problem. So the problems are things like convert between molecules and moles, molecules and grams, grams and moles, any one to any one of the others. And so what I've come up with is a handout that you guys have not had that just has some random conversions for it, actually. And what I've done is I've just made up 1 or 2 of my own, and so that's what I'm going to guide you through now. So, as an example of how to do these conversions, I'm going to convert 321 grams of calcium oxalate into molecules. All right, so if the lighting is good enough for you, there we go. First of all, you have to figure out what calcium oxalate is, and so you go to the list of polyatomic ions and you look up oxalate and you see it's C2O4 with a -2 charge. Meanwhile, on the periodic table, calcium is always a +2 charge because it's in the second column from the left. So In order to come up with a neutral molecule, we'll need one of each, one positive 2 charged calcium with one negative 2 charged oxalate polyatomic ion. And therefore, what I'm after is the molecular formula for calcium oxalate is CaC2O4. Next, I want to calculate how many grams there are in 1 mole of calcium oxalate. And so I go back to the periodic table and I look up the atomic mass of calcium and I see it's 40.078 grams and I need one of those. Next, I need 2 carbons. Each carbon is 12.011 atomic mass units. And I need 4 oxygens. Each oxygen is 15.999 atomic mass units. When I add that all together, I get a total of 128.1 grams for every mole of calcium oxalate. All right, so now I'm ready to convert from grams to moles. The idea is I'm starting with 321 grams. It takes 128 grams to have 1 mole of calcium oxalate. So here's my little conversion table that says 321 grams times 1 mole per 128.1 grams of calcium oxalate is 2.51 moles of calcium oxalate. And the question was, how many molecules, not moles, do I end up with? Well, it's necessary that I calculate how many moles I have first. Now that I know how many moles I have, I can use Avogadro's number that says for every 1 mole of anything, molecules, atoms, shoes, 1 mole is 6.022 times 10 to the 23rd power of that number of items. So 2.51 moles of calcium oxalate times Avogadro's number per mole works out to 1.51 times 10 to the 24th power molecules of calcium oxalate in 321 grams of calcium oxalate. I decided to do one additional example for you, and that is, what if I were to start off with the number of molecules of something, and I want to figure out how many grams that corresponds to? So this is just doing the conversion going a different direction. Starting with 3.21 times 10 to the 24th power molecules of beryllium iodide, I first need to figure out how many moles that is. Well, 1 mole is Avogadro's number. So if I divide 3.21 times 10 to the 24th by Avogadro's number, that works out to 5.33 moles of the substance to start off with. Next, I want to know how many grams are in 1 mole of the substance. So I go to the periodic table and I look it up and I see beryllium is 9.0122 atomic mass units and iodine is 126.90 atomic mass units, and I need 2 of those to make this a balanced molecule. So beryllium is always +2, iodine is always -1, and by crisscross, that means I need 2 iodines for each beryllium. Next, I calculate the total mass for 1 mole, and I get 263 grams for 1 mole. Finally, knowing that I have 5.33 moles of this stuff, 5.33 moles times 263 grams per mole means I have 1,400 grams, 1.4 kilograms of this material. That's a lot. All right, so there's my examples of how to do the worksheet that I've assigned. Good luck.